All right, so we have a little formula that we're going to use for the sake of this class and for the sake of scale factor, and it looks like this here. It's scale dimension is equal to the actual dimension times scale factor. It's exactly what we've done here. So we've taken the actual dimension and we've multiplied it by the scale factor, and that's given us a scale dimension, or that's given us what the model is going to look like. So we can think of this as the model is equal to the actual times the scale factor, and I'm going to use the letter K for that. Okay, scale factor has we can use the letter K. I'll use that sometimes. I'll use other things as well. The way that I'm going to often show it is going to be that the scale dimension, or SD, is equal to the actual dimension, or AD, times our scale factor, or SF. I might replace SF with K. I'll use that interchangeably. These are equal there. Okay, so our scale dimensions equal to our actual dimension times our scale factor, okay, or times K. So let's do a couple of examples that deal with that here. So if we have a model of a TV that is 10 inches long and the real TV is 60 inches long, what scale factor was used in making the model? Okay, this is our model. So this right here is our scale dimension, okay, that's model. And our actual dimension is 60 inches, okay, right there. We want to figure out what scale factor was used to make that. Okay, what did we have to multiply 60 by to get 10? Well, our scale dimension is equal to actual dimension times our K, or our scale factor. I'm going to use K in this case here. If you want to use SF, you can as well, but it can be a little confusing. Let's use K. Now, when we put our numbers in, we know that this is 10 inches, and that is equal to 60 inches times K. And for some of you, you're understanding this quickly with algebra. We can get the K all by itself by dividing both sides by 60. Okay, so I'm going to divide both sides by 60 inches. Now remember algebra, when we divide something by itself, it becomes 1. And when we multiply by 1, nothing changes, so that kind of cancels it out. And so we get here that K is equal to 10 inches over 60 inches. And when we do the division here, inches divided by inches is going to cancel out as well, which means that our K is going to have just a fraction, or we could use decimal. Okay, so this, or 1 divided by 6, this is a decimal, and it's not a super nice one, I believe. Let me just double check, nope. Or 0.16 repeated. We like to use a fraction if at all possible, as it's just slightly more accurate in our descriptions there. So this would be our scale factor. It means that it's a 1:6 ratio, meaning that the model is 1/6 of the size of the original. Okay, it's been made smaller. Okay, the decimal here is less than 1, so that means that it is a smaller model than the original. Okay, so that's a way of rearranging. So if we rearrange that, and I'm just going to quickly go over that, this means that our K value is equal to, and looks like my pen is running out of ink. It's not a good thing. Our K value is equal to our scale dimension divided by actual dimension. So if we set it up as a ratio, that's what it's going to look like. Scale dimension over actual dimension is going to be our scale factor that we can find. Now, let's do something a little bit different here. Okay, number 4, Kipling, Saskatchewan has the world's largest paperclip on display in their park. It is 45.5 feet long. All right, that is monstrous. Our classroom is 30 feet wide, so it's 1.5 times as tall as our classroom is wide. If the scale factor used to make it was 550, how long was the actual paperclip? Well, this is our K value, and this right here is our scale dimension. Okay, that's our scale length right there. And we know that scale dimension is equal to actual dimension times K. And we want to try to find what is the actual dimension of this paperclip. If we punch everything in here, we have 45.5 feet is equal to our actual dimension times K. And so this, K is given here. I can put the K in, I'm sorry about that. We're told that we've used a scale factor of 550. if we divide both sides by 550, that's going to cancel out here, okay? And divide this by 550. Now you'll notice here we have feet divided by numbers, so the feet are going to stay the same. Our actual dimension is going to be 45.5 feet divided by 550. Now we can relate this into a nice little formula. If we want to find our actual dimension, it is our scale dimension divided by k. So that's kind of just on the side there. This means that our actual dimension, if we do the calculations, divided by 550, is 0.0827 feet, which is kind of tough to recognize. So let's just change that into inches, multiply it by 12. This is the same as 0.99 inches, or pretty much 1 inch. Okay, so the paperclip is 1 inch long, roughly. Okay, it's pretty much 1 inch long, and that would be a way of recognizing it, okay, based on using our scale factor. Okay, so there's 3 different formulas that we can use, and I'm just going to highlight them really quickly here. And in fact, I do have a highlighter. We'll see how well this works. Okay, so we know that our scale dimension is equal to actual dimension times our scale factor, or k. If we want to find our k, we do this here. We do our scale dimension divided by our actual dimension. And if we want to find our actual dimension, we do our scale dimension divided by our k value, okay, to figure out what is the scale factor, or sorry, what is the actual dimension that we get.